Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Find the points of discontinuity of f of x where f of x equals x plus 2, comma x greater than or equal to 2 and f of x equals x squared where x lesser than 2, right? So so the function for all values x greater than 2, it takes a value x plus 2, and for all values x lesser than 2, it takes the parabolic function x square, right? And at x equals 2, the function still takes x plus 2, right? So we notice that we can examine the continuity of this problem in three parts, right? So what is part one? Let's write it down. X greater than 2, where for any x greater than 2, the function. And then what do we mean by x greater than 2? X belongs, let me pull the, belongs to the open interval 2 comma infinity, right? And it does not include 2 in part 1, right? We'll have to examine that separately. So let's do that. So part 1 is x plus 2, and we know that it is a simple linear function, x plus 2 for any value belonging to the open interval 2 to infinity, right? So it is continuous. We know that this is a simple polynomial, linear polynomial. So uh, we have discussed this in the past. So we can straight away establish that this is continuous uh, in this particular interval, right? And let's move to part two, which is our x lesser than 2, where we know that my f of x takes a value x square, right? And again, this is a polynomial function. It's a parabolic function, and for x lesser than 2, we know that uh, this function is continuous in x belonging to 2 to minus infinity, right? Because x is lesser than 2 in this particular case. Folks, I'm not going to go into detail and again prove why my x plus 2 is continuous and why my x square is continuous, right? These are simple uh, polynomial functions, and in case you want to work out and see why these functions are continuous, I would recommend that you pick up any number in the defined interval, and you can work it out, right? I don't think it is going to be that complicated, and that's one of the reasons I'm not doing it separately. So I'm drawing your attention to the continuity of some of the basic functions, right? Which you will have to always remember, right? Some of them might be, say, your x squared or x cube or any linear polynomial ax plus b or sine x or cos x. Some of these functions are uh, continuous functions, right? So please remember them. And if it calls for an explanation by working out the details, please go ahead and do it as per the recommendation. Right now, I come to X part 3. We have established part 2, and now we come to part 3, where I know that my function for x equal to 2, I will have to first work out what is my x equals to, right? And what is that? It is x plus 2, right? Because of this, right? And what is my x plus 2? It's 2 plus 2, which is equal to 4, right? And now let me do my f of x equals 2 plus, right? What is that? My right hand limit, right? As I approach 2 from the right hand side, what is the value that this function f of x takes, right? So let me do that here. 2 plus, and what do I get? So it is again x plus 2, and if I'm going to write this as 2 plus h, and I have x plus 2 here, which is 2 plus h plus 2, which is my 4 plus h, which is equal to 4, right? So I'm done with my RHL, and my next step is to go ahead and establish my LHL, right? So which is equal to f of x equals 2 minus, means I again have to look at what is f of x whenever x takes a value which is very close to 2, but in this case it's going to be lesser than 2. And what do we have here? We have the function taking x square, right? So let me highlight this x square, and let me copy it and write it down, right? So I have this function x square, and which is 2 minus h whole square. So let's pull that, and let's put a bracket, and let's sorry let's square it, and I'm going to write this as 4 plus h square, 4 plus h square minus 2h, right? So which is my 4 plus h is infinitesimal, so again I have 4 plus 0 minus 0, which is 4, right? So I have my RHL, I have my LHL, I have my f of x equals 2. So I know that these two are equal, right? My LHL equals RHL, which means that my limit exists, x tending to 2. And then for my continuity, I have f of x equal to 2 also equal to these limits, right? So that's my other condition to establish continuity of a function. And that's also equal to 4, which means that I have a RHL equals LHL, and I have my f of x at x equal to 2 also equal to these limits, right? So I have all the three conditions met for continuity at x equal to 2. So what does that mean? We established continuity in the interval 2 to infinity, which was a simple function, and 2 to minus infinity, it took a parabolic function, which is f of x equals x square, and we know that it is continuous in that open interval. So we left with examining the continuity at x equal to 2, which was the point of concern, where the function took a transformation from x plus 2 to x square, and I'm sorry, from x square to x plus 2. And we noticed that we don't see a break when we represent this function graphically, right? I mean, that's the other way of looking at it. So at x equals 2, the function takes a value 4, and the limit also exists and it's equal to 4. Therefore, f of x is continuous at all x belonging to R, right? So that's how we conclude this particular problem, right? So, folks, I hope you found this content useful. Please do subscribe to my channel and support. Thank you.